Assalamualaikum and a very good afternoon. Okay, my name is Amirul Rahmat. Today, I would like to present basically my teams and I, which is including Akram and also Aizad, will be together with me today. We would like to present the simulation of the ideal optical sensor for the IV converter. Okay, there are three types of sensor that we will cover today, each of us. For me, I will cover photodiode. Akram will cover optocoupler and also Aizad will cover photoresistor. Okay, before we go deeply into this simulation, I would like to basically explain the objective of this simulation. Basically, first and foremost, this simulation is basically want the student to understand the fundamental and characteristic of the physiological sensor based on its physiological strength and also limit, which means that optical sensor is very widely used in the world, especially in biomedical field. Like for us, biomedical student, we have to know about this type of sensor. Okay, and also from the simulation itself, student can know on how to simulate and also to get the signal characteristic and also analyze the voltage, the current, and the power of the circuit and the input and also the output. Okay, photodiode basically is a semiconductor device that will be convert the light into an electrical current. The current basically generated when photons are absorbed in the photodiode. Okay, for this experiment, we would like to know the signal characteristic response, the voltage at the input and output, the current at the input and also the power at the input and also the output. Okay, first, I will show you the signal analyzer is connected at the output. Therefore, we can see here. Okay, this is basically the graph. Okay, I will stop first. This is basically the output from this is the signal characteristic response of this circuit actually. Okay, when we zoom in, we can see clearly here. We can see clearly the graph at this point. Okay, here, and then if we play again, after a few seconds, the graph will then uh, turn to become. Okay, let's wait for 1 second and see in the graph itself, in the signal characteristic response. Okay, after 1 second, it become like this. Therefore, this is the first part, which is signal characteristic response for this photodiode optical sensor. Okay, next. Okay, next, I would like to show on how to get the value of power, voltage, and current at this input part of the circuit. Okay, first I put all the detail here. This power at the input and current. Okay, and also voltage at here as well as current here. Arrange to be make it can see it very well. And also the power we put at the component. Okay, power have to be put at the component. Okay, here already enough. We want to get the power at the input, current input, and also the current and the voltage after going through the resistor itself, and also the power at the component. Okay, for input, we will adjust the value of resistor from 1 ohm to 10 ohm, which means the increment by 10%. Okay, let's start with 1 ohm first. Okay, basically this is the value. Okay, the input voltage here doesn't change because here is 5 volt and the current is 2.91 ampere. But after going through or pass through the resistor of 1 ohm, the voltage slightly dropped from 5 volt to 2.09 volt, and the current remains same after pass through here, and the watt power here is 8.46. Okay, and then I will continue increment the value of resistor until 10 ohm. Okay. Alright. Okay, now I already finished increment it from the 1 ohm to 10 ohm by 10%. And now we can clearly see that here the voltage doesn't change, but the value of the current itself already changed. The power also become smaller, and the voltage here absolutely we can see significantly different from 5 volt here. And now we will move to the output part. Let me clear this first. Okay, now I would like to show you guys on how to get the value of power and also voltage at the output side. We don't have to simulate the current at this part. Okay, first we put voltage here first, and also voltage at this part, power at here, and also power at here. Alright, so this is basically the parameters that we want to know at the output. So let us start. Okay, for the output, the resistor we will change from 100 kilo ohm to 1 mega ohm. Also an increment of 10% from time to time. Let us start from 100 kilo ohm first. Okay, and then we start. Okay, here is the value of the parameters that we want from 100 kilo ohm. Okay, here the power is 48.0 milliwatt and the voltage is 293 nanovolt. Here the power is 0 watt at this level, and also the voltage here is 68.9 microvolt after going through the resistor. Okay, now I will show one by one increment of 10% from 100 kilo ohm to 1 mega ohm. Alright, so here we already simulate the fourth parameter that we want, the two at here, voltage and power here, and power and voltage here. So from time to time we increase the value of R2 by 10%, and we can clearly see the result. Okay, therefore that's all include for me. And now before I pass this video to my friend Akram that will explain about optocoupler, thank you everyone. See you again. Assalamualaikum.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh and very good morning to everyone. Thank you, Amirul, for the explanation before. So let me proceed to autocoupler. So what is the autocoupler means? So autocoupler is an electronic component that transfer the electrical signal between two isolated circuit by using the light. So why we use the autocoupler? So autocoupler can be used to isolate the low power circuit from the high power circuit and to remove the electrical noise from the signal. So autocoupler is most suitable to the digital signal but can also be used to transfer the analog signal. So let's we go to the multisim for our lab. This is for our autocoupler. Says be used a autocoupler, so we need to know the voltage, the current and the power for this circuit. So let we go to voltage first. So I will put this one. This is a point C, and this is a point C voltage, and I will arrange this one. So voltage, so I will take the current also. So this one current, this is a voltage. So lastly I will put the power on the resistor here. So I will put this one. So firstly I will change the resistor to 1, okay, 1 ohm. Okay, let we know the result. So replace one. So for the input for voltage at point C is the 5 volt for voltage 5 volt, and the output is 2.68. Okay, and this one the current is input is a 2.32 ampere here, and the output for this is output for 1 ohm is 2.32 ampere also. So next I will proceed to second one. Okay, I will extend more. Okay, explain more. So I will put this one. Okay, so I will change this one to a 100 kilo ohm first. Okay, so I will put the voltage in this area, and voltage also in this area. Okay, and this one is we just find the voltage and the power for the right side, and this one we put it here, and then we put it here. Right. Okay, next I will play this one. Okay, I will run this one. See, so this one is not one, this is not one, this one, this one. Okay, so the 4 items, I just want to know the 4 item. Okay, this is the result for this one. This the result of the voltage in input is a negative 50.4 microvolt, and the output is 7.8 volt. Okay, we change this one to 100. So that's all for today from me from autocoupler. So we will go to Aizad for the next one. We will go to Aizad for the next one to explain about the photo transistor. Okay, thank you everyone, and happy good day. Thank you.
Hi, my name is Aizad, and I would like to explain about photo transistor circuit that which will be uh, to find out about three elements, which is voltage, current, and also the power. As you can see this at this circuit, for this part we will find the three element first, and then we go to the uh, OP07. Alright, um, we run first, and then for the voltage for 1 ohm, it will show that the voltage for at the point C is 5 volt, at the point D is 2.9. Meanwhile, for the current at point C is 2.91, and at the point D also same 2.91. And then we repeat it. We change it to 2 ohm. for the two element, which is a voltage and a current, we gonna see that the power by the resistor okay. Now we repeat it. We starting at the first point is which is 1 ohm, and we can see the power is 8.46 watt. We increase the resistor value 0.2. Okay, now we go to the second part, which is we need just only two elements, which is a voltage and also the power. For the voltage, we need to find out at point E and point F. Meanwhile, for the power also, we have a 2 point E and also the point F. Alright, okay, now we run. We start up with 1 kilo ohm until 1 mega ohm. So this is our variable that we can change. And then we start 1 kilo ohm first. You can see at the point E, for the voltage is 293 nano and the point F is 68.9 nano. Meanwhile, for the power at the point E, 48 milli, and at the point F also 48 milli. And then we change it. And lastly, we change the value. It's 1 mega ohm, 1 mega ohm, and we've shown that the power is remain constant. Meanwhile, the voltage at the point E and point F. At the point E, it's shown as 292 nano volt and 686 microvolt. Function is to detect light, pulse, and convert them into digital electrical signal. These are operated by light rather than electrical current. It provides a large amount of gain, low cost, and this phototransistor might be used in numerous applications. As I said before, the advantages is gain. The gain is from 0 over 1 per 100,000. With moderate fast response time, can be specially selected to meet requirements that we need in applications. What kind of the medical devices or applications? Applications of the phototransistor is in medical domestic machines. What's mean by medical domestic? It will measure and calculate dose for the treatment of the cancer patients. Alright, what can we conclude that medical instrument sensor help the physicians to diagnose the problem and provide a treatment. It also to measure biological signal and to design a medical instrument throughout the concept of electronic and measure technique that we needed. Thank you.